welcome to Models and Agents, episode 45, on May 11th, 2026. Let's see what shipped. Monday in the AI world, which means a weekend's worth of announcements to catch up on. Let's go. Sakana AI and NVIDIA just showed how extreme sparsity in feed-forward layers can deliver real GPU speedups without retraining. This is not another theoretical paper. The team turned over 99% sparsity into measurable gains on actual NVIDIA hardware. What you need to know is that they combine simple L1 regularization with new custom CUDA kernels. The result is 20.5% faster inference and 21.9% faster training with almost no drop in quality. Local developers will want to watch the latest XLlama v3 updates, while anyone building agents should look at the new persistent memory options now available. In the top story this week, Sakana AI and NVIDIA introduced a method called TwELL. It applies L1 regularization to push feed-forward layers in large language models past 99% sparsity. They then convert that sparsity into real throughput using new sparse data formats and fuse CUDA kernels. The measured gains sit at 20.5% for inference and 21.9% for training. Downstream task performance stays essentially unchanged. Most sparsity research never leaves the lab. TwELL actually ships usable speedups that teams can test on current NVIDIA cards today. If you run large models on that hardware, it is worth checking whether your workloads can adopt the kernels without accuracy trade-offs. Open source releases of the kernels are expected soon. On the model side, Chwen 3.6 35BA3B is showing strong results on niche code understanding tasks. Community tests show it can now take full academic papers plus code and map the implementation back to the research accurately. It outperforms earlier small models like DevStrawl Small 2 on these specialized workloads. The model handles long context through gated DeltaNet and hybrid attention mechanisms that smaller models lacked just months ago. Developers working with technical or academic code bases should compare it directly against Gemma 426BA4B and Nematron 3 Nano for the same jobs. XLlama v3 added DFlash support along with further quantization improvements in its latest release, Fast. The updates deliver up to 3 times speedups on coding workloads and 2.5 times on agentic tasks compared with the previous baseline. New support is included for Gemma 4 and Chwen 3.5 models. Quantization efficiency improved across 3,090 through 6,000 Pro GPUs, with some setups now exceeding 70% memory savings. Local runners should grab the latest dev branch to get the newest caching and DFlash fixes. Moving to agent tools, Memori now provides persistent memory infrastructure for multi-user LLM applications. An open tutorial shows how to wrap both synchronous and asynchronous OpenAI clients, so every model call routes automatically through an agent-native memory layer. It supports multi-session and multi-user scenarios without forcing manual context management. Builders of long-running agents can follow the Colab example and add memory without touching their existing client code. Claude Code can now orchestrate local LLMs as sub-agents through a new pattern. It uses pi.dev RPC mode to let Claude delegate tasks to a local model and then review the output inside the same pull request workflow. The setup keeps the local model inside the agent loop while preserving Claude's orchestration strengths. Developers hitting usage limits should test whether routing, review, or generation steps to a local backend cuts costs without losing quality. On the practical side, a new hands-on series shows how to build small, heterogeneous AI clusters from everyday hardware. The posts walk through networking, Mac Minis, Jetson devices, Raspberry Pis, and old laptops into working clusters for distributed inference and training. Early installments focus on cabling, networking, and basic cluster setup before moving to actual model runs. Anyone with spare consumer hardware can follow along to test whether mixed device clusters make sense for their workloads. Fast. Okay, let's pop the hood on persistent memory layers for agents. Everyone talks about giving agents memory as if it is just stuffing conversation history into a vector store. In practice, it requires careful separation between short-term working memory, long-term episodic memory, and user-specific facts. Without that separation, the model starts hallucinating stale context. The core move is inserting a thin middleware layer that intercepts every model call. It retrieves relevant memories by session and user ID, then injects them into the prompt. This adds only a small constant overhead per request. It removes the need to resend entire histories, which matters once sessions span days or multiple users. The common mistake is treating memory as one undifferentiated store. Without explicit scoping, you quickly pollute the context with irrelevant past interactions. Start with a simple key value layer scoped by user and session. Add retrieval only when context length or task complexity justifies the extra latency. If you have not tried TwELL 3.635 BA3B yet, test it this week on your own academic or niche code plus paper pairs. See whether the long context improvements actually translate to your domain. Pull the latest XLlama v3 dev build and benchmark dflash on your coding or agent workloads against your current inference setup. Follow the Memory Collab tutorial to add persistent memory to an existing OpenAI-based agent without rewriting client code. Start the Mac Minis cluster series if you have spare consumer hardware and want to experiment with heterogeneous distributed inference. On the horizon, more open releases of the sparse CUDA kernels from the TwELL work are expected in the coming weeks. Additional quantization and caching updates for XLlama v3 are already landing on the dev branch. Community experiments with local subagents behind Claude code are likely to produce reusable MCP servers soon. Before we go, keep an eye on those first open source sparse kernel releases from the TwELL team. That's Models and Agents for today. If you found this useful, share it with someone who's trying to keep up with all these changes, and subscribe so you don't miss tomorrow's update. The AI world moves fast. We'll help you keep up. See you tomorrow. This episode used AI voice synthesis of my voice. Editorial selection and analysis are my own.